Okay, so this video we are going to discuss on February-March 2022, paper 1-2. Okay, so let's have a look for question number 1. There's a curve with equation, and they give us the differentiation of this equation, which is f prime x equals to 2x negative power negative 1 over 3 and minus x power 1 over 3. And it is given that f8 equals to 5. So from here, they want us to find out the equation of fx. Okay, so to find the equation of fx from f prime x, we need to do the integration. Right? So I'm having this as the differentiation f prime x. Okay, so to get the function fx, we need to apply the integration for this equation. So I'm having this. Alright, so to apply the integration, generally we copy the constant to copy the x. The power negative 1 over 3, we have to add 1. So plus 1 become 2 over 3, and we divide the new power, which is 2 over 3. Minus, I copy the minus. So for the second term here, power is 1 over 3 plus 1. So 1 over 3 plus 1, I have 4 over 3. And of course, divided by the new power. And we have a plus c at the back. Alright, so we should further simplify it. For this part, I will have 3 over 2 multiplied with 2x power 2 over 3. For this term, I will have 3 over 4 multiplied with x power 4 over 3 plus c. And of course, you can simplify it for the first term and end up you have this 3x power 2 over 3 Alright, so of course, if we want to get the complete equation, right, we should try to find out the constant c. So how can we find the constant c? We can actually try to apply, okay, or substitute the information given here into our equation. So from this part, you know that the 8 is actually the x. Therefore, you should know that x equals to 8, and the 5 here will be generally the value for function. So I'm going to apply it in our answer here, where I have 5, which is equals to, and I substitute all the 8 into the x. Okay, so we should try to simplify all this. Okay, so for this term, if you don't want to use calculator, right? So 8 power 2 over 3, where you take the cube root for the 8, you get a 2. So 2 square, you get a 4. So for this term, you're having 3 multiplied with 4. And for this one also the same. Alright, so take the cube root of 8, which is a 2. So 2 power 4, you will get a 16. So I'm having 3 over 4, then 16 plus c. Okay, so by substituting the value and try to simplify everything, you will have the value where c is equals to 5 actually. And our complete answer for the function fx will be equals to 3x power 2 over 3 minus 3 over 4 x power 4 over 3 plus 5. So this is actually how we get the complete answer for the function fx. Okay, so question number 2. Alright, so they give us the equation where y equals to x squared plus 2cx plus 4, and there's another straight line which is y equals to 4x plus c, and c is the constant. And they want us to find the set of value for c for which the curve and the line intersect at 2 distinct points. So when the curve and the line intersect at 2 distinct points, Alright, so generally what you should do is like you have to try to find out the intersection point for this line and also the curve. Therefore, I'm going to equate the curve with the equation of the straight line. So I'm having 4x plus c. Definitely, I cannot solve this equation. Alright, so I'm going to rephrase everything to one side. So I will have 2c minus 4 bracket x and also 4 minus c, and it is equals to 0. So I'm having the quadratic equation in terms of x, right, and also the c. And now, since we know that the curve and also the line intersect at two distinct points, that means the discriminant for this quadratic equation will be greater than 0. Okay, so where is the b? So b will be 2c minus 4 here, the coefficient of x. So it will be 2c minus 4 squared minus 4. A is the coefficient of x squared, which is the 1. And the c will be the constant term, which is 4 minus c, and it is equals to 0. It will be greater than 0. All right, so we'll try to expand everything here. And let's see what will we get. Okay, so we try to expand everything, then we rephrase it again. So I will have 4c squared minus 12c greater than 0. And after that, I can try to factorize it. And this is what I get. Okay, so from here, I can see very clearly that I have two critical values for c. So the critical value will be c equals to 0 and also c equals to 3. So by using these two critical values, you should try to decide, okay, where is positive and where is negative. All right, so I'm having these two critical value. For me, I'll draw number line. Okay, so the number line denotes the bracket lah. So like for this one is the bracket c minus 3. So that means at this part, the bracket c minus 3 is positive. At this part, the bracket c minus 3 is negative. And then for the bracket of 4c here, okay, I draw a line to the right hand side. That means for all the part with the line, okay, the 4c will be positive. And if I substitute any value on this part, the 4c will become negative. Right, so when you multiply the 4c and c minus 3 together, so positive multiply positive, overall you get a positive. So positive, negative, overall you get a negative. Negative and negative, overall you get positive. Alright, so I want to decide my final answer. So to decide the final answer, I'm looking at my step. The last step before I draw the number line or find out the critical value. So I'm looking for greater than 0, which is positive part. So in overall, my equation will be positive when I'm having c value equals to this one and also the c value equals to this. And when I write out the answer, it will be c smaller than 0 and also c greater than 3. Which means that if I substitute my value of c, either it is any value smaller than 0 or greater than 3, right, into the equation, my equation here will be a positive value, and eventually it actually will make us to have this quadratic equation with two distinct roots or two distinct points, intersect two distinct points. Right, so this is how we solve question number 2. Okay, so now we come to question number 3. Okay, so for question number 3, they are asking for the term that is independent of x in each of the following expansions. Right, so let's have a look for the first one. Okay, so to find out the expansion with which is independent of x. So to find out the expansion that is independent of x, generally maybe you have to try an error. So the general formula will be 6c something, and then I'm having 3x power something and also 2 over x squared. Okay, so for the power that you can put here, right, the total of these two powers should be equals to 6. where you have a few options, such as you can have 0, 6, and then 1, 5, 2, 4, 3, 3, and so on. Okay, so you can try to try and error. So maybe you can try to try the value, try to put in all the power here and see which one fulfill what we want here. We want the term that is independent of x. So for me, before I apply or try and error, right, I will have a look for this term and also the 2 over x squared. Definitely the power for 3x must be larger than the 2 over x squared, so that I can cancel off these two terms to get the term which is independent of x. Alright, so all the power, the smaller power in front, I will ignore, and I will start from this one. So if I substitute 4 here and 2 here, x power 4, I get a 4. 2 square power 2, I also get a 4. Then from here, x power 4 divided by x power 4, you get a constant term. So this is how we decide the correct power. Alright, so I'm having the 4 and also the 2. And for the combination 6c, the number here will follow the power at the back, which is 6c2. Alright, so trying to press the calculator, 6c2 will be equals to 15. 3x power 4, you will have 81 x power 4, and then 2 squared is a 4, and also x power 4 here. Alright, so when you try to simplify everything, you will get a term which is independent of x. Okay, it will be a constant term, and the answer should be 4860. Alright, then now we proceed to part number B. So for part number B, they are also asking for the term that is independent of x. Alright, so you can see that from this part, generally it is from part A. And for the second bracket here, outside is a power 1. So 1 minus x power 3, we don't need to expand anything. It will remain as it is. Alright, so for 3x plus 2 over x squared, I will know that for the first term, in this bracket 1 multiply with a constant term to get a constant term. So if I'm having 1, multiply with the constant term from this expansion. So the constant term from this expansion, I already get it just now in part 1, which is 4860. So I will substitute 4860 here. And after that, for the second term in the first bracket, negative x power 3. So negative x power 3, right? We actually need to multiply with something so that I can also get a constant term. So I will look for the term which has 1 over x power 3. Something with 1 over x power 3. Alright, so that x power 3 multiply with 1 over x power 3. When you cancel off these two terms, then you will get a constant term. But the problem now is we need to try and error again from this expansion to get the term with 1 over x power 3. So again, we are having all the possible power 0, 6, 1, 5, 2, 4, 3, 3, and so on. Alright, so I want to try an error now. So again, I'm having 6c something also, then 3x power something, 2 over x squared power something. So what is the power that I should put for the bracket of 3x and 2 over x squared? Again, we want to have 1 over x power 3 in this expansion. Therefore, in my opinion, right, we should know that maybe this power, okay, must be slightly larger than what we have here, right? Okay, all right, so by try and error, if let's say I put a 4 here and also I put a 2 here, this power 4, x power 2 power 4, you have 1 over x power 8, and for this one you have x squared. And when you multiply x squared with 1 over x power 8, you have x power 6, which is not fulfill what we want. We want to have something with x power 3. Alright, so that means this is too large. we will not get that 1 over x power 3. Maybe you can try the next power, which is 3 and 3. So if you put in the 3 and 3 here, you will have 1 over x power 6. Then for this one, you have x power 3. So x power 3 multiplied with 1 over x power 6, you will get something with 1 over x power 3, which is something that we want. All right, so you already know that the power that we are using now should be 3 and 3. Okay, so I rewrite everything again here. So after the trial and error method, we get the power, which is power 3 and also power 3. Then of course 6C3. Okay, so I will try to put in all the value. Okay, so 63, 3 power 3x power 3, and this one, when you multiply everything together, you will have the term which is 4320 multiplied with 1 over x power 3. Okay, and I know that for the constant term 1, multiply with the constant term to get the constant term. And for the term with x power 3, I need to multiply with the term with 1 over x power 3, so that eventually I will get a constant term too. Alright, so when I take 1, multiply with 4860, I have 4860. When I take negative x power 3, multiply with this whole thing, then I'll have negative 4320. So end up, I will have the constant term for the whole expansion, which is 540. Okay, so this is how we solve. Okay, so question number 4. All right, so we have the first term of geometric progression and the first term of animatic progression are both equal to A. Okay, so I think this is quite simple. Right, so we have the third term of the geometric progression is equal to the second term of the arithmetic progression. All right, so the third term of the geometric progression will be AR squared, and it is equals to the second term of the arithmetic progression. So I can write out the equation where AR squared equals to second term, which is A plus 1D, right? So from here, I can rephrase it like if you want. And this is the first equation or information that I get from the question itself. Okay, then continue. The fifth term of the geometric progression is equal again to the sixth term of the arithmetic progression. So from here, I think we can form another equation where the fifth term of geometric will be AR power 4 equals to the sixth term of the arithmetic progression. So I'm having A plus n minus 1D. So 6 minus 1 is 5. And this is my second equation. All right, so from all the sentences here, we can form two important equations here. And next, given that the terms are all positive, so please take note that all the terms are positive and not all equal, find the sum of the first 20 terms. So what is the sum for first 20 terms? So it will be S20. And they want us to find the sum of the first 20 terms, okay, in terms of A. All right, okay, so let us try the S20 first. So to find the S20, the general formula will be N divided by 2, 2A plus N minus 1. So N minus 1 is 19D. Okay, so 20 divided by 2, I get a 10. Right, so 10, if I multiply with 2A, I will have 28. And then 19 multiplied with 10, I will have 190D. Okay, so if you look at this question, they are actually asking for the sum of the first 20 terms in terms of A only, in terms of A. But in my answer here, I'm having something with D, which means I have to substitute the D, okay, by using something which is related to A. Okay, so to make the D disappear, maybe it will be very useful for us to find out a useful information from these two equations. Okay, so I'm having R squared equals to A plus B, sorry, A plus D over A, and this is the second equation I get. So to get rid of the R, So first I need to get rid of the r first, right? So that I can express d in terms of a. So to get rid of the r, what can I do is that I will substitute the equation number 1 into equation number 2, where I will have a r power 4, I can write become a plus d over a and then square. That equals to a plus 5d. Okay, then now if I want to try and simplify everything, what am I going to do now is I expand this bracket. So I'm having a square plus 2ad plus d square divided by a square equals to a plus 5d. Okay, so from here you already can see that the r disappear. We already get rid of the r. And now we have to rephrase our equation so that we can have d in terms of a. Alright, so to have d in terms of a, I need to simplify it first. Then for left hand side, I'm having this. And for the right hand side, I will have a squared plus 5ab. Okay, then I will further simplify it. From here, you can see that a squared and a squared can be cancelled off. And from here, I will have d squared minus 3ad, and it is equals to 0. So again, I will have d, factorize out the d, and then d minus 3a equals to 0. So from here, we'll get two values for the d. So d is equals to 0 and also d equals to 3a. So for the d equals to 0, right, we will ignore it because of in the question itself, they already tell us that all the terms are not equal. So if your d is equal to 0, that means your terms will be all equal, Therefore, we ignore this one so that we have all the terms which is positive and also not the equal terms. Alright, so from here I get a very important result where d equals to 3a, which means that I can substitute it into my steps now. So what is the d? D equals to 3a. Alright, so from here you can try to add everything together and you should have 598. Therefore, you can see that my final answer, right, S20, the sum of the first 20 terms is equals to 598, which actually fulfill the request of the question. So the question wants us to have the answer in terms of A only. Therefore, our final answer should be 598. Okay, so we are now at question number 5. All right, so they give us the expression and they want us to express it in this form. So for this form, generally it is the completed square form. All right, and then please take note that for this completed square form, they want us to have a 2 outside the whole completed square form. Okay, so we will start from the expression that they give us. And before we apply or before we start the completing square process, we have to make sure that the coefficient x squared is always equals to 1. Therefore, I will take out or factorize out the 2. And this is what I get after I factorize out the 2. Alright, so now I will start the process of completing square. So I'm having plus something square minus something square. So the something should be negative 4 divided by 2, which is negative 2 and also negative 2. Alright, so I try to combine the first 3 terms as one bracket with a square outside. So I'm having x minus 2. Expand this one, I will have negative 4 plus 7. And eventually I will get 2 with the bracket of x minus 2 square plus 3. And this is exactly the pattern that they want us to show. Right? Then now let us proceed to the part B. now they tell us that the function f and g are defined by this and also this one. So what we need to take note is about the function gx. So if you observe carefully, the function gx is actually the expression that we have in part number 1. And of course, we should try to link that this expression can be written as 2 and then the bracket of x minus 2 square plus 3 from what we did in part number 1. Okay, so what they want us to do now is they want us to describe fully a sequence of transformations that maps the graph fx onto the graph of gx, making clear the order which the transformation are applied. So originally I'm having x squared, and what are the transformation process so that we can lead to this expression. All right, so we are going to write out all the possible transformation. All right, so the first transformation here, what we can observe is this one. I'm having the -2, that means the horizontal translation with the vertical translation. All right, so for me, I will make it in this way. So the first one, I will translate 2 units to the right. So that means this is a horizontal translation, followed by 3 units up, also translation, right? So translate 3 units up. So this is a vertical translation. So horizontal translation and also the vertical translation. So if you want to swap these two translation together, swap the sequence of these two translation, also no problem. That means you can translate it 3 units up first, after that followed by translate 2 units to the right. Okay, and for some of us, right, you will write in another way where you write in this form. So translate 2 and also 3. Also can, because the 2 means 2 units to the right, 3 means 3 units up. All right, so you can either write it in this form or either you separate it into 2 different transformations. So after we go through the translation, then the last one will be a stretch. So we multiply the 2 outside the whole function. So that means it is a vertical stretch. So the third transformation will be a vertical stretch. And we need to let them know what is the stretch factor. So with a stretch factor 2, okay, because we multiply the 2 outside the whole function, right? So this is the 3 transformations that we apply, okay, to change the x squared become this form. Okay, so question number 6, they give us a diagram and they tell us that we are having the circle. So this is a circle equation. Then we have the straight line equation as well. All right, so it cut through the circle at point A and B. So the center of the circle is at C. So here is the point C. All right, so for first part, they want us to calculate the coordinates of A and also the B. So very obvious coordinate for A and B. The point A and point B are actually the intersection point between the line and also the curve, the circle. All right, so to solve and get the intersection point, usually we need to solve simultaneous equation where we substitute this value into the circle equation. All right, so my circle equation will look something like this now. So I'm having x plus 1 square. What is the y? So y is 3x minus 20 and minus 2 square. And it is equals to 85. Okay, expand the x plus 1 square. I will have x square plus 2x plus 1. And for this bracket, if I try to simplify it, I will have negative 22 square, which is equals to 85. Again, I further expand the second bracket with the square. So I'm having x squared plus 2x plus 1. When I try to expand this, I will have 9x squared negative minus 132x, and also I'm having plus 484, which is equals to 85. So from here, generally we can have a look that it is actually a quadratic equation, okay, in terms of x. Therefore, I will want to move all the terms to the left hand side. So I'm having 10x squared, then negative 130x, and plus 400, which is equals to 0. So I can further simplify it. Alright, so from here, I realize that I can solve the quadratic equation by factorizing them. So I have x equals to negative 8. X minus 8 equals to 0. Therefore, I'm having x equals to 8. And also, this one is x equals to 5. So these two will be the x coordinate for the point A and B. Alright, so for this question, they're asking for the complete coordinates. That means besides the x coordinate, we also need to find the y coordinate. So substitute the value x equals to 8 into the line equation so that we can get the answer in a more straightforward way. So when 8 is substituted into this equation, so 8 times 3 is 24, minus 20, I have a 4. The same thing happened for x equals to 5, substitute into this equation, so you're having y equals to negative 5. Okay, so observe the location of the point A and also point B on the diagram. So from here, we can actually simplify that, or we can actually conclude that A is actually the point with 8, 4. Then B will be the point, which is 5 and negative 5. So this will be the coordinates for A and also B. All right, and now for part B. All right, so for part B, they want us to find an equation of the circle where the center is still the C, and then this circle is actually having the tangent, which is the line. So that means, in short, that means we are still having the same line, and now we are having another circle where this circle, okay, actually have a tangent, which is on the line. Okay, all right, so maybe I draw it like this. It will be easier for us to have a look. Okay, so I'm having another circle. Okay, the center is still at C. Okay, and then for now, right, definitely the A and B will not be in the circle anymore. Okay, so when the line is a tangent of the circle, generally we should know that they are 90 degree to each other. Okay, so the center of the line to the point that touch the circle, or which is the tangent of the circle, right? Okay, will be perpendicular with the line AB. All right, and now what they want us to do is that I have to form the equation for this circle. Okay, we already have the center. So the center C here, according to the original equation that is given, I know that the coordinate of the C is -1 and also 2. All right, so my aim now, or my steps now, is to find out the R, the radius for this new circle. So if I can find out the radius of this new circle, then I can form the equation of the circle. All right, okay, so there are a few ways that we can try to calculate the radius. So for me, what I can see is, for this line, this is the radius, right? This is the radius, and it is actually the perpendicular distance from the point C to the line AB. Okay, so I'm having the line AB where it is equals to y equals to 3x minus 20. Okay, so if I change the equation into a standard form, I'm having 3x minus y minus 20 equals to 0. All right, so now I want to find the radius, and this radius is actually the perpendicular distance from point C to the equation AB, to the line AB. So I can write in this form, R is equals to the perpendicular distance from C to AB. Okay, so what is the formula for perpendicular distance from C to AB? All right, so just to recall, the formula is the distance is equals to modulus AX 0 plus BY 0 plus C divided by square root of A square plus B square. So I believe that we actually learned this before. All right, so the AX plus by plus c is actually belongs to the line equation. And for the x0 and y0, you are substituting the point which has the perpendicular distance with the line. Okay, so to apply this equation in our example here, in our question here, so what am I having now is I'm having ax, so a is a 3 lah, according to our equation here, so it will be a 3. X is actually the x coordinate for the C, which is -1, then minus y. So y is a 2 minus 20 and divided by square root 3 square plus, because our A here is 3, right? And then the B will be -1. So plus -1 square. All right, so this is actually what I have for my when I want to apply the perpendicular distance formula, okay, from C to AB, then I will further simplify it. Okay, so if I simplify this whole thing, I put the modulus, I'm having 25, and then divided by square root 10. So this will be my radius. And the center of this this circle is actually -1 and 2. So since I already have the center and I also have the radius, therefore what we can do now is we can form the equation of circle. The equation of circle will be x minus the center, right? Okay, so x minus x0, and my center is -1. So when I put it inside the bracket, it will become +1. So I'm having x plus 1 square, then plus y minus 2 square equals to r square. So equals to r square means I'm having this 25 over square root 10, and then we have a square here. All right, so you can leave your answer in this form if you want, or you can maybe square the r. All right, so when you try to square this value, I will have 25 square divided by 10. Okay, and it shows that I will have 125 over 2. So this is the equation of the circle where it has a tangent at the line AB. All right, so this is how we solve this equation. Okay, so question number 7. They want us to show that this is what we have now. Okay, the equation. Okay, so for us, right, we can see very clearly that the left hand side is more complicated. So we'll start from the left hand side, and we can combine them, become one fraction on the right. All right, so for me, I will start from the left hand side here. Okay, so for my left hand side equation, this is what I have lah. Okay, so this is what I have. And then for the very first step that we need to do is like very obvious. We have to combine these two fractions become one, because we are having only one fraction on the right, correct or not? So for these two fractions here, we should actually combine them become one. So when we combine them become one, that means we multiply the denominator together, which is cos theta minus 2 sine theta, cos theta plus 2 sine theta. All right, and after that, for the numerator, you need to cross multiply this to the top and this one to the top as well. So if I write it in detail, it will look something like this. So sine theta plus 2 cos theta multiply with cos theta plus 2 sine theta. At the same time, we are having sine theta minus 2 cos theta multiply with cos theta minus 2 sin theta. So the step is very, very long here. Okay, so now let's try to simplify. Maybe we can expand all the brackets first and then we try to simplify that. So for the denominator, if you try to expand everything, right, we will have cos square theta minus 4 sin square theta. So this is my numerator, denominator. Then now I focus on the first part of numerator. So for this first part of numerator, you need to expand all the bracket also. First term multiply with second term multiply with first, second term multiply with second term. All right. So you just try to expand these two brackets here. Okay, when you expand the front part here, you will have sin theta cos theta, then plus 2 sin square theta plus 2 cos square theta, okay, and then plus 4 sin theta cos theta. So this is when I expand the first part, and this is what I get. Okay, then minus, now I want to expand the second part here. So for this second part, when I expand it, eventually I will get something like this, sin theta cos theta minus 2 sin square theta minus 2 cos square theta, and also plus 4 sin theta cos theta. So this is the expansion after I expand the second part. Okay, so next step. So for the next step, right, again, we will start from the denominator. If we observe the denominator, generally you can see that our denominator should have only cos square. But in my solution here, I'm having something with sin square. That means I have to try to apply some identity so that I can make the sin square disappear. So for cos square theta minus 4, so sin square is actually equals to 1 minus cos square as well, right? That's one identity that we always apply. So sin square plus cos square equals to 1. Therefore, sin square is equals to 1 minus cos square. All right, then come back to numerator. Come back to numerator. Right, so for the numerator, for the first part, sin theta cos theta plus 4 sin theta cos theta. So I'm having 5 sin theta cos theta. Okay, so for this part, generally it is 2 times of sin square theta plus cos square theta. So sin square theta plus cos square theta equals to 1. And eventually I'm having only a 2 for this part. So this is the first part after I simplify the first part on top here. Okay, then now I want to simplify the second part. Okay, so again I still put the minus. So sin theta cos theta plus 4 sin theta cos theta, I'm having 5 sin theta cos theta. Alright, then how about for this one? So for this part, generally it is at negative 2, and then I'm having sin square theta plus cos square theta. So again, sin square theta plus cos square theta, very obvious, it is equals to 1. Therefore, I left negative 2 here. So I'm having negative 2. Okay, so when you complete until this step, then generally you can see that our answer is very, very close to what they want us to show. Okay, so again, I will look at the denominator one more time. So for this part, cos square theta plus 4 cos square theta. So you already get the 5 cos square theta. And then negative 4 multiplied with 1, you have minus 4. And again, if you double check the denominator, we already achieved what they want us to show. Okay, then for the numerator on top, if you expand everything, you will see that the 5 sine cos can be cancelled off with the 5 sine cos. Alright, can minus each other. And then 2 minus negative 2, you get a value of 4. So very obvious, you can see that we already get the equation that they want us to show for the right hand side. Okay. Alright, so the step is a bit long, but generally if you know the idea and just expand it, then after that you simplify slowly. Of course, you can get the answer that they want you to show. Right. Okay. Then Then now let's continue to part number 2. So for part number B, they want us to solve this equation equals to 5. And then for the range where theta is from 0 until 180. So again, for this part, it is actually the left-hand side of the equation that we show on top. All right. So to solve this equation, we can straight away substitute the answer that we show on the right-hand side, which is this equation, this expression, sorry. So I'm having 4 divided by 5 cos square theta minus 4, and it is equals to 5. All right. And then I bring the cos square theta minus 4 up. Okay, and after that, if I try to simplify everything, that means I move all the number to the other side because I want to solve for the solve for the theta, right? So if I bring everything to another side, I will have cos square theta equals to 24 over 25. Okay, so what is the value of the cos theta? So I take square root. Okay, so when I take square root, I need to consider the plus and minus sign. So that means later when I want to get the answer for the quadrants, right, I need to consider all the quadrants that include positive cos and also the negative cos. All right, so we proceed further. After this step, to find out the angle, usually I will try to find out the basic angle first. So the basic angle is actually cos inverse. So for us, we are having cos theta here, right? Therefore, the basic angle will be cos inverse the value of square root 24 over 25. And what did I get is I get 11.5. Okay, so now I want to use this basic angle to find out the answer for the theta. Alright, so I go through the quadrant. Okay, so for the first quadrant, cos is positive. Therefore, I want to accept the answer from first quadrant. So the answer from first quadrant is actually the basic angle itself. Okay, and after that, I go to the second quadrant. So in the second quadrant, cos is negative. And in our solution here, I actually want to consider cos equals to negative as well, right? So the second quadrant answer, I also want to accept. So how to get the second quadrant answer? You take 180 minus the basic angle. All right, so 180 minus the basic angle minus the 11.5. And therefore, the answer for second quadrant will be equals to 168.5. Correct to 1 decimal place. Okay, so I will stop at the second quadrant because of from the question, they request from 0 until 180 only. Therefore, it only consider the first two quadrants and we accept both answers from the first two quadrants. Okay, so this is how we solve this question number 6. Okay, so question number 8. All right, so we have a diagram, and this diagram shows the circle. So the circle equation will be x minus 2 square plus y square equals to 8. And the chord AB of the circle intersect the positive y-axis at 8, and it is parallel at the x-axis. Okay, so again, this line AB is actually parallel to the x-axis here. So for first part of the question, they want us to calculate, or they want us to get the coordinate of A and B. All right, so maybe I can start from this point first. Since the A is the y-intercept, therefore we know that at this point, the x is equals to 0. Therefore, for this equation, the circle equation, right, when x is equals to 0, what is the value for y? So I'm having 4 plus y squared equals to 8, and therefore I'm having y equals to plus minus 2. Okay, so when y equals to plus and minus 2, right, from the diagram, very obvious, from the diagram, the value of y should be a positive value. Therefore, I can make a conclusion that the coordinate of A is actually 0 and 2. Okay, so since I already know that the value of y is equals to 2 at point A, therefore at point B, since they are parallel with the x-axis, right? So the point B also having the same value of y, which is y equals to 2. And now I want to substitute y equals to 2 into our original circle equation to find out the b. So x minus 2 square plus 2 square equals to 8. My x minus 2 square is equals to 4. If I continue further, then I will have x minus 2 equals to plus minus 2, and the x value should be equals to 0 and also the 4. Okay, so again, according to this diagram, you can see that the x coordinate for b is not a 0. Therefore, from here, we can also make a conclusion that the coordinate for b will be actually 4 and also 2. Okay, so this is how we actually get the answer for the coordinate of A and also the B. Alright, and now if we proceed to part number B. Okay, so for part number B, they want us to calculate or find the volume, okay, of revolution when the shaded segment bounded by the circle and the chord AB is rotated through 360 degrees about the x-axis. Okay, and now they are asking us to find out the volume. So maybe I can put the answer here. Okay, so for the volume part, to get the volume, of course, we need to apply integration. Okay, and then for the formula of volume, this area that we are interested is actually bounded by the curve and also the horizontal line. Okay, so we already have the curve equation, and then for this horizontal line, generally the equation should be y equals to 2. Okay, so you can see that for this area, it is covered by the circle first. Okay, circle is the higher function, and then the line is the lower function here. Okay, so since it is covered by the curve and also the line, when I apply for the completing square, sorry, when I apply the integration so that I want to get the volume, right, the formula generally will look something like this. It will be by y square by y1 square dx minus by y2 square dx. So this is for the case where my area, the area that I'm interested in, is bounded by two curve or maybe two function. All right, so the area here, very obvious, it is covered by a curve and also a line. So the general equation will look something like this to find the volume. Okay, so I will now substitute all the formula inside the steps. I will take out the pi because pi is a constant. Okay, so what is the y1 square? So the y1 square will be the function on top. So the function on top is this one. So circle equation is this. Okay, so I want to substitute the y square. So y square, very obvious, it is 8 minus x minus 2 square. Okay, and what's the limit? So you can see that the value that the area start is this point where x equals to 0, and the value where the area end is at this point, which is x equals to 4. Therefore, the limit of the integration should be from 0 until 4. Okay, then minus again for the second part of the equation, it is still pi. I will take it out, and then the range is still the same from 0 until 4. Therefore, the limit is still from 0 until 4. So what is my second equation for the y? So the second equation of the y is actually the lower function. So this lower function is y equals to 2. And I want to integrate y squared. So y squared means that 2 squared, which is a 4. Okay, so generally this is the equation that we have to integrate to get the volume later. Alright, so maybe before I apply the integration, I will observe the pi and the pi here are the same. The limit are also the same. Therefore, I can combine them, become one integration. So 8 plus 4. 8 plus 4, I'm having, 8 minus 4. 8, then you have a minus here, right? So 8 minus 4, you get a 4. Therefore, you're having 4 minus x minus 2 square dx. Okay, so it seems like everything cannot be simplified anymore. So I will start the integration. So integrate 4, I'm having 4x. Integrate a bracket with a power outside, I will copy the bracket, power plus 1, which is a 3. So divided by the new power 3. Differentiate x minus 2, you get a 1. So you should multiply a 1 here like at the denominator. Okay, then I need to substitute the limit 4 and 0 now. Okay, so when I substitute the value 4 and 0, first part 4 multiply with 4, you get a 16. 4 minus 2 is a 2, so 2 cubed you'll get 8, so 8 over 3. Then minus, now you substitute 0 into the equation, so you're having the 0. Substitute 0 here, then you will have plus 8 over 3. Okay, so try to simplify all the values inside here. Alright, so try to simplify all the value inside, and you can get the answer, which is 32 over 3 pi unit cubed. Since this is a volume that we want to find out. Okay, so if you don't like to keep your answer in this third form, then of course you can change it become 3 significant answer. So if you want to change it become 3 significant answer, it will be 33.5. It will be also accepted because for this question they didn't request for the exact volume. So you can put it into 3 significant figure, or you can keep it in the pi form. We come to question number 9. Okay, so for question number 9, they want us to solve the equation fx equals to 0, where the fx is given here. Okay, and then giving a solution in the form of x equals to a plus b sub c. And then the a, b, c must be the integers. Okay, will be the integers. All right, so we'll start solving this equation. My function f is x minus 4x power half plus 1 equals to 1. Okay, so this is generally a quadratic form equation where you can let y equals to x power half. If you can see the terms, the variable clearly, right, you no need to change the x power half into the y. If let's say you cannot see it, then you just try to let y equals to sub x, okay? And then for x, you're having sub x, sub x then square. Therefore, I'm having y squared. So minus 4y plus 1 equals to 0. So from here, you can see in a clearer way that I'm having actually a quadratic equation. Okay, then from this quadratic equation, of course, I can solve it. I want to solve it. All right, so to solve it, I realize that I cannot use factorized method to solve this, and therefore I use a quadratic formula where it will equals to negative b plus minus b squared minus 4ac. So b squared is a 16 minus 4ac and divided by 2a. Okay, so if I try to further simplify this, I will have 12. And next step, for the third 12 or square root 12, I can further simplify, become 2 third 3 divided by 2. And therefore, I will have 2 plus minus square root 3. Okay, since the y is actually my square root x, so I will let my square root x equals to 2 plus square root 3, and also square root x equals to 2 minus square root 3. Okay, so I want to get the value of x, therefore I try to square it. So I bring the third form over, become square. So I'm having 2 plus square root 3 square, and another value will be x equals to 2 minus square root 3 square. Okay, so if I continue to expand this part, I will have 4 plus 4 square root 3 plus 3. Then for the second part of the x, I will have 4 minus 4 square root 3 plus 3 as well. And further simplify this. Okay, so this is the two solution that I get. All right, so maybe you need to do a little bit of checking, because in the domain given in the function f, right, the x must be greater or equals to 0. So maybe by pressing calculator, you try to have a look whether this value of x, are they greater than 0 or not. So very obvious that these two value of x are actually greater than 0. Therefore, I accept both answer for this fx equals to 0. So you can see that it is clearly that we are having the x in terms of a plus b square root c. Okay, then now let's continue to part number b. Okay, so for part number b, they are telling us that fx is equals to ghx, and they want us to find the value of m and also n. All right, so fx is very straightforward, which is x minus 4x power half plus 1 equals to ghx. So ghx is actually a composite function. So I will take the g first. I will want to put in the function h into the g. So function h, I'm having square root x minus 2. I will write it here, square root x minus 2. Substitute the square root x minus 2 into the function g. Therefore, if you look at the function g, you are having m, and then the x square, the x itself, you replace it with square root x minus 2. Okay, so if I continue from here, I will have m, and then x square, right? So x square means that I substitute half x power half minus 2 and then square. This is mx square, then plus n. And I will equate it to the left hand side, which is still the same. Okay, so from here, right, to find out the value for m and n, we need to expand the right hand side so that we can directly compare the right hand side with the left hand side. Okay, so the left hand side will remain the same all the while. Okay, so for the right hand side, you take m, expand the square. For this bracket, I'm having x minus 4x power half. Then I will have plus 4 plus n outside. Then again, I try to multiply in the m into the bracket. Okay, and I try to compare it with the left hand side of this equation. Okay, so I think it is quite obvious that we can see in front of the x, it is a coefficient 1. And on the right hand side, we are having mx. So from here, we can say that m is actually equals to 1. So you just straight away compare the left hand side and the right hand side. Okay, so once you already know the value of m, then now we can compare the constant term. So for the constant term on the right hand side, we are having 4m plus n. The constant term on the left hand side, we are having 1, which means that I'm having 4m plus n equals to 1. And since you already know that m is equals to 1 also, right? So your n will be equals to 1 minus 4. And therefore, you get the answer n equals to negative 3. Okay, so we get an answer for m and n by actually comparing the expression on both sides. Okay, so question number 10, we are given a diagram which shows that we have two circles here. One circle is with the center A and radius is 5 cm. Then the center B, another circle with center B with the radius 8 cm. So the circle touch at the point C so that the AC and B is a straight line. The tangent at the point D, okay, on the smaller circle intersect the larger circle at point E and pass through the B. Okay, so this is the information given for this diagram. Okay, so please take note that we are having actually a right angle triangle. Okay, that that is part of the two circle. All right. Then if you have a look in detail, since this is a right angle triangle, right, we are having the hypotenuse, which is 13 cm, and then we should have this length, which is the radius, 5 cm. All right, so for this right angle triangle, we are having the length for two sides. One is this 5, another one is the hypotenuse, which is equals to 13. Okay, so first part of the question, they want us to calculate or find the perimeter of the shaded region. So to get the perimeter of the shaded region, generally you can see that it is actually covered by three sides. Okay, the first side will be this one, which is the length of DE. The second side will be this arc, the curve, okay, the arc DC. And the third one will be the arc EC. Okay, so when we want to calculate the length, okay, the value for the arc DC and arc is EC, right? Generally, we need to know what is the angle DAB and also angle DBA. Okay, so for the angle DAB, which is this one, okay, if I take the cos of this angle, then I will have 5 over 13. All right, so the adjacent length over the hypotenuse. Okay, so I'm having 5 over 13, and therefore the angle DAB will be actually equals to cos inverse 5 over 13. Okay, so I'll keep it in this form first because I will substitute this term into the calculation later. All right, then now let's have a look for this angle. This is the angle DBA. So I will see, you can see that the sine for angle DBA is also equals to 5 over 13. Okay, where it is the opposite over the hypotenuse, opposite length over the hypotenuse, so it is 5 over 13 for sine DBA, which means that the angle DBA will be equals to sine inverse 5 over 13. Okay, so some of you might want to write this answer as 90 degree minus cos inverse 5 over 13, which is also correct. All right, so as long as you try to figure out, okay, what is the angle for DAB and what's the angle for DBA. All right, so now I want to continue with my calculation here. Okay, to get the length DE, it is actually the length DB minus 8, right? Because minus the EB, I need to minus this one. So to minus this length, it is actually 8 cm. Okay, so I will take dB minus 8 cm. Okay, now I will start to calculate the arc DC. So the arc DC is r theta. R for the circle, so smaller circle will be the 5, right? So r theta, theta means angle DAB. So this is a theta. Therefore, I will have r theta, it will be 5, then cos inverse 5 over 13. Okay, then for the arc EC, again, the arc EC is actually from the circle, a bigger circle, the larger circle. Then the r theta will be 8, r will be 8, and the theta here will be this one, dB8. So you will have 8 sine inverse 5 over 13. Okay, then continue further. What is the length for dB? So generally dB is, you can find out by using the Pythagoras theorem. Okay, where we are having square root 13 square minus 5 square. Okay, then minus 8 again outside. Then I copy this. Okay, so we can try to get the answer by pressing calculator. So one reminder here, when you want to press calculator for the answer, because of we are having the trigo function here, sine inverse and also cos inverse. So you need to make sure that your calculator is in the radian mode. Okay, so please make sure that you change become radian mode before you press the calculator for the answer here. All right, yeah, so 13 square minus 5 square, square root minus 8 this whole part you will get a 4. Okay, and of course the remaining part here you just press the calculator and try to get the answer, and after that you try to add them together. Okay, so if you didn't do any careless mistake when pressing the calculator, the answer that you get should be 13.03835499. And of course, we will change it become 3 significant figure as our final answer. Therefore, our final answer for this part will be 13.0. So this is actually the perimeter for the shaded region. Okay, all right. So next part, part B. Okay, so for part B, they are asking us to find the area of the shaded region now. So again, I will rewrite it one more time. For this angle, the angle DAB is equals to cos inverse 5 over 13. And the angle DBA is actually sine inverse and 5 over 13. Okay, and now we'll focus on how to get the area of the shaded region. So to get the area of the shaded region, okay, so generally what we need to have is we are having the area of triangle minus the sector DAC and also minus another sector BCE or BEC. Okay, so this is how we actually find out the area of the shaded region. Okay, then now let's start. For the area of the triangle, because this is a right angle triangle, and we already know that the length of DB is 12 cm just now. Okay, so the area of triangle will be half multiplied with base multiplied with height. Okay, then minus the sector DAC. So for the sector DAC, the formula will be half r squared. So r is the 5. A half r squared theta. So the theta will be the angle DAB, which is cos inverse 5 over 13. Okay, then minus the sector BEC, which is half. And then we are having 8. So 8 squared theta. So the theta will be angle DBA. It will be sine inverse 5 over 13. Okay, so again, straight away pressing the calculator for this part, you'll get a final answer. So another reminder, because of it involves sine inverse and cos inverse also, therefore our calculation part here in calculator, right, you have to set it become the radian mode before you press the answer for this step. Alright, so if you didn't do any kind of mistake, then generally the area, the shaded area for this part will be equals to 2.67, correct to 3 significant figure. Okay, so this is how we find out the area of the shaded region. Okay, so now we come to the very last question, question 11. Okay, so it is given that the curve, a curve has an equation of this, and the k is a constant. Right, so first part, they want us to find in terms of k the value of x at which there's a stationary point. So when we're having the stationary point, generally we need to find out the dy dx and we let them equals to 0. So I'm having y equals to k 3x minus k power negative 1 plus 3x. Okay, so to find out the dy dx, k is a constant with the bracket with x, with the variable x. Therefore, the k I will just copy it. And now I try to differentiate this bracket. So to differentiate this bracket, you bring the power front. So you have negative 1 in front. Copy back the bracket, power minus 1, which is now become negative 2. And after that, you need to differentiate the thing inside this bracket. So differentiate 3x minus k, you will get a 3. Okay, so for the next term is a plus, so I just put a plus. Differentiate 3x, we get a 3 as well. Alright, so I try to simplify the first term here. So to simplify the first term, I will have negative 3k over 3x minus k squared and plus 3. Okay, so at the stationary point, right, our gradient of tangent at stationary point is equals to 0, always equals to 0. Therefore, I'll let dy dx equals to 0. So from here, I'm trying to solve for the value of x in terms of k. Right, so I will move the first term to the left-hand side. Okay, and after that, I will try to move the k, sorry, move the bracket with the x to the right. Okay, simplify the left-hand side, and I will have 3x minus k squared, which is equals to k. Okay, so take the square root. When I take the square root, right, I need to consider the both value for plus minus square root k. And then if I want to get the value of x, I will have 1 over 3 plus minus square root k plus k. So if you want to look at it in detail, right, generally we are having two answers for this part. The first answer will be k plus square root k. Another answer will be k minus square root k. Okay, so this is this is the value of x that we can get in terms of k when the curve has a stationary point. Okay, then now we can proceed to part B. All right, so for part B, now they are talking about the function f. Okay, and function f also has, they tell us that it has a stationary value at x equals to a, and it is defined as this equation. Okay, so there are a few things that we need to know. Okay, when they are giving us the function fx, right, if I compare it with what I have just now, you can see that they are having the very similar pattern. Okay, and if you compare them, you will realize that actually the value of k is equals to 4 in the function fx. All right, so you can see that the k is actually the value of 4. Okay, and then the second thing is they are giving us the domain. So the domain for function fx should be greater than 3 over 2. All right, therefore, if we want to get any value for the x, we have to make sure that we double check this condition. Okay, our answer must fulfill this condition where x must be greater or equals to 3 over 2. Okay, so they want us to find the value of a and determine the nature of the value. Since they already tell us that a is actually the x coordinate for the stationary point, therefore we should try to figure out the value of a from this equation, this answer, and also this answer. These two answers are actually the x coordinate for the stationary value in general, right? Okay, and now we already know that the k is equals to 4. Therefore, my value of x should be equals to 1 over 3 and then 4 plus square root 4. Another answer for x will be 1 over 3 and then 4 minus square root 4. So if you try to simplify all this, okay, first answer that we get will be a 2. The second answer that we get here will be a 2 over 3. Okay, then according to the restriction here, the domain given, x must be greater or equals than 3 over 2. And we can see very clearly that we will ignore this answer because the 2 over 3 is not in the domain given. All right, therefore, since x equals to x equals to 2, and we will know that a is actually equals to 2. Okay, so after we get the value of a, now we need to determine the nature of the stationary value. All right. Okay, so to determine the nature of the stationary value, we need to apply the differentiation for the second time or the second derivative. All right, so I will have a look for the first derivative that I have just now. This is my first derivative. Okay, I will continue from here to get the second derivative. But at the same time, I will try to substitute the k as a value 4. Okay, so I will start from this part. I will write again my f prime x. So my f prime x is actually negative 3k. K is a 4 in the function f, right? Then divided by 3x minus 4 square plus 3. So if I rephrase it again, this is what I have. Alright, okay, so now I will want to have the second derivative now. Okay, so for the second derivative, I copy the negative 12. I bring the power in front, become 12 multiplied with negative 2. Copy the bracket and the power minus 1. So negative minus 1 become negative 3 now. And after that, I need to differentiate the thing inside this bracket. Differentiate 3x minus 4, you get a 3. Okay, so here we ended the differentiation for the first term. Now we go to the second term. So second term is a constant. So when you differentiate a constant, I'll get a 0. Okay, so again, we try to simplify and rephrase the answer for second derivative. All right, so from here, I will have 24 times 3. And then for the denominator, I will have 3. For the x, I need to substitute the x coordinate for the stationary point. So the x coordinate is equals to 2. So I substitute the 2 here, minus 4, and also the whole thing power 3. Okay, so for the second derivative value, I'll get a 9, and it is actually greater than 0. So when you're having the second derivative value which is greater than 0, it tells us that the stationary value is actually a minimum value. Okay, so please make sure that you make a complete conclusion. All right, so the answer will be a minimum value when I'm having the second derivative is greater than 0. All right, so now we continue to the third part. Okay, so for the third part, they give another function, which is the function gx, and the domain is x greater equals to 0. All right, so they want us to determine and making the reasoning clear whether g is an increasing function, decreasing function, or neither. All right, so usually when you want to investigate now whether the function is increasing or decreasing, generally we need to have the gradient of tangent. From the gradient of tangent, we will know that where is the function increasing and where is the function decreasing. Okay, so this is my original function gx. I want to find out the differentiation for the gx. So I want to find out the g prime x. Okay, so negative, I just copy. Negative 1, I'll put in front and copy the bracket, power minus 1. So negative 1 minus 1 become negative 2. And again, I want to differentiate this thing inside the bracket, I will get a 3. And then plus 3x, when I differentiate it, I will have a 3 as well. Okay, so when I try to simplify this part, right, I will have 3 over 3x plus 1 square plus 3. So this is the differentiation, okay, for the function g, which is a g prime x. And this g prime x, when you substitute any value of x, right, it will actually tells you the gradient of tangent. All right, so if we have a look in detail for this part, okay, when you're having a bracket with a square outside, it means that this whole bracket is always give you a positive value. All right, because we are having a square. No matter what is the value that we have for the value of x, this whole bracket with a square outside will be a positive value. So 3 divided by a positive value is positive, plus 3, it is also positive. So you can see that this whole expression here will be positive regardless to any value of the x. So you can make a simple conclusion here where g prime x is always positive. Okay, so regardless to the value of x. Okay, so when the g prime x or f prime x is always positive, it actually means that our function is always increasing. Therefore, you can make a conclusion where the gx is an increasing function. Okay, so this is how we determine, all right, whether the g is increasing, decreasing, or neither. Okay, the increasing or decreasing function. All right, so here we ended all the questions for this paper. Thank you very much for watching.